Alright, zoology students, we're in the home stretch now. Today we're going to start our last phylum for the year, and that is going to be Phylum Chordata, and this is the phylum that we would be classified in. Okay, so these are going to be some animals that hopefully you will be more familiar with, since most of the animals that people are familiar with do classify as members of Phylum Chordata. So let's go ahead and get started. All right, Phylum Chordata, and we're getting ready to find out that Phylum Chordata is the characteristics of chordates are they have to have a dorsal nerve cord. It's supported by a notochord, which we're going to talk about, and they have a postanal tail and will contain pharyngeal gill pouches, and we'll get a little bit more detail into those characteristics here shortly. So without further ado, let's go ahead and get things started. Characteristics of Phylum Chordata. The first one is that all members of Phylum Chordata are going to have bilateral symmetry. So if we go back and we think about one of our first groupings that we talked, one of the first phylum was Phylum Echinodermata, which were the sea stars, sand dollars, and sea urchins. They had radial symmetry, which means that their body parts radiate out from a central axis, and they can be divided into multiple planes that would equal right and left portions, equal halves. Bilateral symmetry is there's only one plane that you can use to divide the animal to get equal right and left portions. And as we see on this kudu here, that plane is going to be right here. Okay, that divide, if you go down that animal's body that way, that would divide that animal into equal right and left halves. And this colorful tropical frog down here, its natural coloration gives us, look at that yellow line that runs right down the middle between his eyes, and that is the only plane that you can use to divide that animal into equal right and left halves, and that is bilateral symmetry. All right, next, the characteristics of the Phylum Chordata is they have a segmented body with 3 germ layers. So this takes us to our embryological development. So before we are even an embryo and basically a zygote or ball of cells, our cells will start to layer and differentiate. And those 3 layers are spelled out right here. The ectoderm, which is going to be the outer layer, the mesoderm, which is going to be the middle layer of cells, and the endoderm, which is going to be the inner layer of cells. And we find out that this is where our cells begin to differentiate, and this is the beginning of them starting to become different tissues. So the ectoderm cells are going to form the skeleton, for example. The mesoderm are going to become the internal organs, such as the liver and the stomach and intestines and so on. And the endoderm forms the inner lining of the organs. So the stuff that's going to be inside those organs, especially the GI tract, okay? That's where those cells begin to do their own thing. Instead of just being regular old general animal cells, they're going to start to specialize and develop into the cells that are going to become their organs. All right, next, they have a well-developed coelom. And remember, we've talked about coelom before. Coelom is a true body cavity, okay? So different versions, we have an acoelomate, a pseudocoelomate, and then what we are is eucoelomate. So A in front means it has no body cavity. So acoelom means absent, body cavity is absent. Pseudo is a prefix that means false. So it has a body cavity, but it's not considered to be a true body cavity. And whenever you see the prefix EU as in you, that means true, and this is a true body cavity. So here are the differences. The acoelomate, no body cavity, okay? Pseudocoelomate has a body cavity, but it is false. And by false, we mean that one side is surrounded by the mesoderm and the other side is bordered by the endoderm. Okay. Now, if you look over at a true coelomate, a eucoelomate, you can see that the coelom or body cavity is completely enclosed within the mesoderm. All right. So that means inside and outside of the body cavity is enclosed with mesoderm. That is us. That is how our embryo develops, and that is where our body cavity will be found. And so we are also in a what is called a eucoelomate. All members of Phylum Chordata must possess a notochord, which is a notochord is basically, think of it as a support beam. Now, as it turns out, our singular dorsal tubular nerve cord, as our spinal cord, it happens to be encased in a spinal column, a column of vertebrae. Some, and very few, this goes back to the Flipgrid Friday question about true false, are all members of chordata vertebrates? The answer is false, because you can have all the characteristics but not have your spinal cord or not have your dorsal nerve cord contained within a spinal column. Right? It can be supported by a cartilaginous rod called a notochord. And when we are developing embryos before our spinal column develops into a spinal column, we also possess a notochord that will then later grow into and develop into the spinal cord. All right, so that's the difference. It is basically just a supportive structure that the dorsal nerve cord will rest upon. And that's the difference between notochord and the spinal column. Okay, so here is an example, as you can see in this picture, of this lovely organism here. This is the spinal cord. You can see right there, and underneath of it is this red supportive rod called the notochord. Okay, so this dorsal nerve cord is not wrapped and encased in a vertebral column. All right, so it's just supported by the notochord, and as long as it has a notochord, it can be a member of Phylum Chordata. Pharyngeal gill pouches must be present at some stage in the life cycle. Now, some of you are probably thinking to yourselves, oh, I didn't know I had gill pouches. And once you are born, you're right, you really don't have gill pouches. But when you were really, really small and very early in your embryological development, you did have the beginnings of the gill pouches, which would mean if you developed, if your DNA said that you were going to grow gills, you would have a place for those gills to develop. Clearly, we don't have gills, so they close up and are absorbed by the normal developing of the human body plan. But fish, on the other hand, those gill pouches will develop into an area for their gills to develop. And many scientists believe that the fact that our embryos develop gill pouches suggests that we hail from a common ancestor, and that it shows that we have evolved from an organism that at one point had gills many, many, many millions of years ago. So here's an example. All right, so here are some very early embryos. As they develop, as you can see, they really they all kind of look the same, but you can see in a fish there are going to be the gill slits or gill pouches. The reptile, depending on what kind of reptile it is, will also develop along these lines with gill pouches. Now, as we know, reptiles don't have gills, but there they are. Birds don't have gills, but there's its gill pouches or gill slits. And of course, the human embryo, very early, it will show those gill pouches. So that is a characteristic of Phylum Chordata. We also have what is called a postanal tail, which means there is a tail that extends post or past the anus, usually projecting beyond the anus at some stage, but may or may not persist, which means, again, let's go back. Here we go. Look here. This human has a tail. All right. Now, this is going to be where the hind legs are going to develop, and as the human embryo grows, the body extends and kind of absorbs that tail and grows past it so that the tail is not visible. We do still have a tailbone called the coccyx. For those of you that came out of my anatomy class, hopefully that sounds familiar. But as we grow and develop, we don't really establish a visible postanal tail. But we had one during our embryological development, again suggesting evolving from a tailed animal. They have segmented muscles and an unsegmented trunk. So our muscles, if you have done any dissection of a vertebrate, you know that our muscles are segmented into packages, and they are easy to identify from each other because they are separated from each other. That's what that talks about. And our trunk is not segmented the way an insect's body is segmented, is what that means. Our trunk is just one big major portion to our bodies. Characteristics, continuing of characteristics of Phylum Chordata. We have a ventral heart, which means our heart is very close to the ventral surface. Our ventral surface is towards the front of our body, that's our chest. And dorsal ventral blood vessels. So that means we have very large blood vessels that run either along our spine or along the inside of our chest. And for those of you who have coming from anatomy again, you remember we talked about the aorta, which runs along our spine, and then coming right into the right side of the heart, we have the superior and inferior vena cavas, and they run along our ventral body surface. So we show both of those. And of course, we have a closed circulatory system, which simply means that our blood is not ever supposed to leave our blood vessels and our heart. It stays within that system 100% of the time, as long as there's no injury. We have a complete digestive system, meaning we go from mouth to anus, and cartilage or bone endoskeleton. Okay, so as we develop, our cartilage begins, or excuse me, our skeleton starts off as cartilage, and it will later develop into bone. But some chordates, such as sharks, for example, their skeleton remains cartilage their entire lives, whereas ours is cartilage and grows into bone. And even after we're born, we still have part of our skeleton as cartilage that will develop into bone. And as you grow through adolescence, your growth plates are cartilaginous plates that develop into bone, and that's how our bones grow and get longer. But the key is we have an endoskeleton, which of course means our skeleton is on the inside of our body. All right, so that gets us through the characteristics of Phylum Chordata. So I think at this point we know the drill. Once you finish this video, log on out of YouTube, head on over to Schoology, find exit slip for Phylum Chordata Lesson 1, and go ahead and complete that. All right, so good work today, and we'll talk to you later.